Okay, let's come to this concept called as convexity. Now, we initially learned duration. Duration is helping us in calculating something called as volatility. Now, let's take an example. Volatility is 4%. Okay, yield changes by 1, 2, 3, 4, 5, 6, 7. Yield is changing by these percentages. Question says yield goes up by 1%, 2%, 3%, 4%, 5, 6. What volatility says is this is yield change. Bond price change according to volatility is 4 into 1, 4 into 2, 4 into 3, 4 into 4, 4 into 5, 4 into 6, 4 into 7. This is called linear relationship. What is linear relationship? Is rate of change is same. The rate of change is same. You would have learned about something called as diminishing marginal utility, where the rate of change, when it happens, it does not happen exactly 444. The rate of change is also slightly different. Here the concept says the rate of change is going to be exact 4% for every 1% change. But in practical world, this does not happen. Just to give a number, I have a 5-year bond. I have a 5-year bond whose base price is 100. Okay. When yield changed from 10 to 9, you saw a change of 3.89. 100 became 103.89. Can you tell me in calculator 107.99 minus 103.89? 107.99 minus 103.89. So for the first 1%, it was 3.89 change. This is intrinsic value. For the next 1%, it is some 4.1. 4.1. 112 minus 107. Then 116. So you will keep seeing this change happening different. You will keep seeing this change happening. What volatility has told us, the change is going to be constant. What volatility is told us, the change is going to be constant. Practical world, it doesn't happen. Practical world, the change does not happen to be constant. Now this is using volatility. This calculation is using volatility or duration. I started with 100. Extra 3.79 because volatility in this question was 3.79. Everywhere I added 3.79, everywhere I deducted 3.79. 1%, 3.79, you kept on adding, 3.79, you kept on deducting using the concept of volatility, because volatility will tell percentage change. Unfortunately, this is the error I see. If I do intrinsic value, 100 rupees, 100 rupees is the base. But if I go through volatility concept and I go through real intrinsic value, what is real intrinsic value? Is year, cash flow, PVF, DCF. There is a gap which you see. As I was explaining, duration concept or volatility concept is good for a small change. So when 1% change happened, this is the change. 10 becoming 9, 9 becoming 8. This is the YTM. 10 becoming 9, 9 becoming 8, 8 becoming 7, 7 becoming 6. When the YTM change is small, I don't have a problem. When the YTM change is small, I don't have a problem. But when the YTM change is large, there is a problem because you see an error happening here. You see an error happening here. This error will have to be adjusted using a concept called convexity. What is convexity? I'll touch in some time. But this error which is there. Now, moment you bring in convexity, what is convexity? We'll see it later. This will be the revised estimate. This will be the revised estimate if you bring in convexity. That is base price plus or minus volatility adjustment plus convexity. Why plus and not minus? I'll explain all that later. But if you bring in convexity and then calculate the error is lesser. Still error will be there. Still error will be there because this is also approximate calculation. This is also approximate calculation only. But if you go through only duration, duration or volatility is the first derivative of the price equation. Convexity is the second derivative. You will have to do differentiation d square p divided by dy square. You will have to do technically that second differentiation. If you do third differentiation, fourth differentiation, fifth differentiation, then only this error will be 0.0. This error will still continue to be there because like you have error due to duration. Now graphically it will look like this. You see this, there is a line which is in blue. You will see blue is not a straight line. There is a small curve which is happening. That small curve basically indicates that the intrinsic value does not linearly change. Whereas the gray line is a straight line. What it says is 100 extra 3.79, extra 3.79, extra 3. It's a straight line. It is a straight line because it is saying extra 3.79 or less 3.79. The graph is just saying that. Whereas if you bring in the real valuation, if you do a real valuation, you see a gap. The gap which you see in this graph, there is a small gap. You may not be, it may not be very clearly visible for you, but let me do this. You see a small gap. The blue one is the price as per intrinsic value, and the gray one is the price as per the volatility concept. That gap will try to be reduced, that gap, through convexity. You cannot make that zero. You cannot make that zero. This is the concept of convexity. What convexity is trying to do is, whenever you are doing volatility, along with that, please calculate convexity also. Along with that, if somebody says with volatility I'll find the price change, no, with volatility alone you cannot find. You also need to bring in the concept of convexity, so that you'll be able to appreciate the price change. So the error which you see in this calculation, the error goes down. The error goes down if you bring in convexity. This was just a 5-year bond. If the life of the bond is higher, the error will also keep increasing. This is a 10-year bond where the error is 11 rupees, starting from 11 rupees till 7.87. Using the concept of duration, what you get, and using the real intrinsic value, what you get. So using both, I have done the calculation. When you do using both, you see the error being there. And when it's a perpetual bond, the error further goes up. Error can even go up to 90 rupees. The error, perpetual bond means the life is very high. The life is very high. The error percentage further goes up. In fact, in this, even after doing convexity, I have an error. Even after doing convexity, I have an error, because the problem, even after doing convexity, why you still continue to have error is because that was the second derivative. Bring in the third derivative, which mathematically there is no name to it. Fourth derivative, fifth derivative, sixth derivative, seventh derivative. This concept of duration, volatility, convexity is ideally useful for small change. What is small change? At best maybe 2% or 3%. At best 2% or 3%. Practical, well, interest rate from 10 is not going to go down to 1, or from 10 is not going to increase to 20. So when you have a small change, the duration itself is sufficient for a small change. 9 or 11, the error is only 0.10 or 0.09. This error also you can eliminate to a great extent by bringing in the concept of convexity. By bringing in the concept of convexity, you can remove this error to a great extent. Any doubts till this? Clear? What is concept of convexity? Concept is the bond price as per convexity, as per volatility, has a linear relationship. The change has a linear. What is linear is 1%, 1% change, 10% is the impact. 2% 20, 3% 30, 4% 40, 5% 50, 6%. Now you will reach 110% itself. Bond price cannot fall by 110% at all. So you may even reach a stage where it will say 110% fall, which is not possible because you cannot have a bond price becoming negative. But unfortunately, duration or volatility says linear relationship. This linear relationship, you want to do some correction on that. That correction will happen through convexity. Any doubts till this? Now, I have given a formula and a format in my class, in my material. I'm changing that because ICAI has given a different formula. Both gives the same answer. Both technically give the same answer. Now, what happens is, what they are saying is, what is convexity is, you need not write the formula. 100 is the base price. 100 is the base price. When reality it goes to 9, the increase is 3.89. The increase is 3.89. When it falls, the fall is 3.70. This numbers, okay? 100. When the yield is going down, price is increasing by 3.89. Price is going down, it is 3.70. At this stage itself, I have a problem with the concept of volatility. Because when price is going up or going down, you say same percentage. But in reality, 3.89% and 3.70% is happening. So what they are saying is, for convexity, you start with 10. You take any two prices, either 9 and 11 combination or 8 and 12 combination, one fall, one increase, 1% fall and 1% increase. So my base is 10. Let me take the 9 and 11 as the calculation. You can even take 8 and 12 also. A small change. Don't take 2 and 22. All that is not going to work. So from 10, 100 basis point fall, 100 basis point up, or 200 basis point fall, 200 basis point up, or 300 basis point. Don't go beyond that and all. Beyond that, you go up, it will lead to errors in convexity because it can afford only a small change. It can afford only a small change, because when you have a larger change, Why it cannot afford is when you have a larger change, you will have to go through third derivative, fourth derivative, fifth. Because when you have a larger change, the third derivative will have a value. In this question, if you see, the first derivative 100 becoming 103 is the change because of the first derivative, extra 3.79, extra 3.79. The second derivative change is only 0.10. The second derivative change is only 0.10. Third derivative, if you calculate, that will be 0.001. Fourth derivative 0.0001. Fifth derivative, because the impact will keep going down. The impact will keep going down. Now I cannot do so many derivatives, are practically not possible. So they say if you have a small change, be happy about it. When you have a bigger change, then you need the third derivative, you need the fourth derivative, you need the fifth derivative, because the impact of the first item, when you have a bigger change, the first one is impacting 22 rupees. As per volatility, you have to increase it by 22. That is the first derivative change. Then you have to change 3.49 because of convexity. The third derivative will be extra 1 rupee maybe. Fourth derivative could be extra 50 paise, 20 paise. I am not doing all that calculation, but I am just trying to say that when a change is very high, you need the third derivative, you need the fourth derivative, you need the fifth derivative, you need infinite derivatives. There can be infinite derivatives. The percentage impact will keep going down. So the impact because of volatility, when you do a problem, volatility will say 4%, convexity will say 0.5% or 0.25%. Then the third derivative, if you calculate, it will say 0.1%. Fourth derivative will say 0.001%. Fifth derivative will say 0.00001%. It will keep having that percentages. Beyond two derivatives, there is no point in going forward. So let me take 9 and 11. Let me take 9 and 11. The price at 9% is 103.89. 103.89, and price at 11 is 96.3 in my calculation. Okay, 103.89 and 96.30. 103.89. This is for one person. I'm doing calculation for one person. 103.89 and 96.30 are the broad numbers. I've taken the broad numbers and written them. 103.89 and 96.30. Now on these numbers, what we are going to do is, I'm going to subtract this with 2 into the base price. I've taken one price above, one price below, one price above and one price below, and multiplying with 2 into 100. Multiplying this with 2 into 100. Can you tell me what is this number? Point. Basically looking at 100 basis point, looking at just 100 basis point. I'm just looking at 100 basis point. The duration is saying same change. The duration is saying same change. If it was same change, then the formula is 103.79 plus 96. This is duration, okay? 103.79 plus 96.21 in minus 2 into 100. Tell me how much you get. 103.79 plus 96.21 minus 2 into 100. 0, which means no convexity. If reality it was happening like same change, convexity does not exist. In reality, if the same change was happening, convexity does not exist. Convexity is existing because same change is not happening. So in short, the convexity is half of this number. Why half? Because you have taken two prices. You have taken two prices. That is one price above, one price below. Can you tell me this number? 0.19 by 2. 0.09. This is the final convexity adjustment for 1% change. Final convexity adjustment for 1% change. Final convexity adjustment for 1% change. 2% change, take the 2-year price. Do in the calculator. 107.99 plus 92.79. 107.99 plus 92.79 minus 2 into 100. Point. Divide that by 2. Point. So you see the convexity adjustment. 0.39, 0.39, 0.10, 0.10. That is the convexity adjustment. Basically, I'm trying to reduce that error which is there. Why does an error happen? The error is happening because it's not uniform change. It is not uniform change. This is the final convexity adjustment. This is not convexity. There is a convexity number which needs to come. I'll come to that in some time. But this is the final convexity adjustment. Take 3 year, that is 3%, 112.3 plus 89.45, 112.3 plus 89.45 minus 2 into 100. Divide that by 2. That is the convexity adjustment. 0.87, 0.87, 0.87 and 0.87. I'm taking two prices. I'm taking two prices. Because I'm taking two prices, I'm dividing by 2. Because I'm taking two prices, I'm dividing by 2. The formula is called V plus V minus V plus it's there in the theory. It's there in the theory. V plus, just listen for some time. V plus V minus 2V0 minus 2V0. What is V plus? Is price which will be there if yield goes up by 1%. 1, 2, 3 you can decide. Okay, price which will be there if yield goes up by 1%. For example, 96.30 is the price if it goes up by 1%. If it goes up by 1%. V plus means the price which will be there when yield goes up by 1%, and V minus is the price which will be there when yield goes down by 1%. Subtract minus 2 into the base price. Why 2 into the base price? Because you are comparing with two prices. If you see this as 0, it means it has a linear relationship, which is not going to happen. Linear relationship is not going to happen. But if in case you see is 0, you should be very happy because it has linear relationship. You are done. But linear relationship is not going to work out, because what happens is the bond prices I showed you, 100 became extra 3 rupees, 4 rupees, 5 rupees, 6 rupees. You will see the change happening. You will see gradually the change happening. Any doubts till this first? Any doubts till this? Why I'm dividing by 2 is division by 2 basically indicates that I'm taking average of this impact. Average of the impact. In theory, I have a different formula. Sorry, in my practical portion, I have a different formula, but I felt this is better because this is what I said. V plus V minus 2V0 divided by 2. Just leave it till this as of now. Leave it till this as of now. There is an extra part I'll explain. There's an extra part I'll explain. This is the final convexity adjustment. This is the final what I gave you is the final convexity adjustment. What is this? This is the formula of convexity. This is not convexity adjustment. What is convexity adjustment is convexity which you calculate using this formula into whatever is this denominator. Whatever is this denominator, please multiply that. Yield change square. So into yield change square, you'll have to multiply into V0. Into V0 you multiply. That will be the final convexity adjustment which you got directly. Because I told you just divide by 2. Don't do anything beyond that. Don't do anything, because this and this portion will get cancelled. This and this portion will get cancelled. The denominator has V0. What does V0 is? If you divide by price, you get the answer in percentage. Whatever that 0.09 you told me, I want you to divide by the base price. You will get the answer in percentage. Like volatility is 3.15%. You can say convexity is 0.25%. You can say convexity is 0.25%. So in the formula, they say you please divide by 2 first. Why you are dividing by 2? Division by 2 is to take the average of the change. You can divide by V0 also. You can divide by V0 also. When you divide by V0, you get the answer in percentage. You get the answer in percentage. After that, you can do into 100. Into 100 is doing it in percentage. All that you can keep doing. But if you divide by V0, you'll get 0 point something into 100 to express it in percentage. Now, why this comes? Yield change square. I'll discuss on that. It is the second derivative. It is the second derivative. First derivative is the impact because of yield changing. Second derivative is the impact because of yield changing one more time. Is the impact because of the yield change. So mathematically what happens is there is a y. Y is called yield. Then there's a delta y. This is called delta y, is basically the yield changing. The next time yield change, it's called delta square y. Delta square y. The yield changing twice. The yield changing twice. What is the impact of that is what? Convexity. Second derivative. It is the second derivative, which is the impact of the yield changing. When I say yield changing twice, does not mean 10 becoming 11, 11 becoming 12. 10 has become 11, which is a 10% change on a base of 10. 10 became 11. If that extra change 1%, on that, what is that extra 10%? Because mathematically you can keep doing second derivative. 10 became 11, extra 1. On this extra 1, if you take 10%, on this extra 1, if you take 10%, it is 11.1. What is that 11.1 is? 10 became 11. On this extra 1%, if you take 10%, is 0.1. Then on this 0.1, if you take 10%, it is 11.11. On that extra 0.01 if you take, that is called derivation. Derivation is keep on assuming the change will happen infinite times on the change portion. So when you do base, it's called y. When you do change, it's called delta y. When you do the second change, it's called delta square y. What you do in volatility is volatility multiplied with delta y. Volatility multiplied with delta y. Convexity says multiply with delta square y. Multiply with delta square y. In volatility, if yield is going down, let's assume minus. If yield is going down, you will see an impact happening opposite side for us. Yield going up or yield going down, you will see an impact happening opposite side. What will happen is, if yield is going up, price is going to move in the opposite direction, and if yield is going down, that happens. In convexity, what happens is, yield going down, minus into minus will become plus. Minus into minus is going to become plus whenever convexity change is there, because in duration volatility, if yield is going up by 1%, price will fall by 3%. But in convexity, price will not fall. Price will only go up. Price will only go up because yield square. When you do, if yield is going down, minus into minus will become plus. Minus into minus is going to become plus. I'll ask you, what is the yield change? You'll say minus 1%. I'll do minus 1 into minus 1, it will become plus. Minus 1 into minus 1, it is going to become plus. So the convexity adjustment is always added. You see, this is the base price. This is the convexity adjustment. I only add convexity adjustment. I only add the convexity adjustment. Everywhere I would have added. Whereas this part, I add sometimes. And I also deduct sometimes. 100 became 96. 100 became 96 is subtracting the impact of volatility. Volatility is the first derivative. Volatility is the first derivative which is based on yield change. Convexity is the second derivative which is based on yield change square. Which is based on yield change square. When you square a yield change, whether you have a negative change or a positive change, final impact is positive. Final impact is positive. So this convexity adjustment is always added to the base price. It's always added to the base price. Whereas volatility impact sometimes is added. For example, when I say sometimes added, 100 is the base price. 100 you can add 3.79, you subtract 3.79. You are adding as well as subtracting. Whereas convexity part, only addition. Only addition. So what is the final prices? Base price plus or minus volatility change. Plus or minus volatility change. Based on volatility. What is volatility change? Volatility into change in yield. 2%, 2% into volatility. 1%, 1% into volatility. 0.5%, into volatility. Yield going up, price will go down. Yield going down, price will go up. Inverse relationship. Plus convexity adjustment. Always plus. Convexity adjustment is always to be added to get the final price. Convexity adjustment is always to be added to get the final price. And if you see this error is always positive. Error you see is always positive. It is basically saying that what you get through duration is always lower than what is the real price. What you get through duration is mathematically always lower than what would have happened if you had followed intrinsic value. If you had followed the intrinsic value approach, you would have got the right value. You would have got the right value. That right value is always lower, always higher than the duration value. So error is always there. This error is brought down by impacting convexity adjustment, by bringing an impact of convexity adjustment. Any doubts till this? So to summarize the formula, you take V plus V minus minus 2V0 divide by 2. 2 is to take the average. V0 is done to express it in percentage. V0 is done to express it in percentage. Yield change square. Yield change square. You will divide by yield change square. You will divide by yield change square. Once this is done, you can again multiply this with V0 and yield change square. You can multiply this with V0 and the yield change square. That is the final convexity adjustment. Because question will ask, what is convexity? Convexity is this portion. What is convexity is this portion. What is convexity adjustment is remove this. Remove this, that is the convexity adjustment. What will finally be adjusted is what is volatility? 3.81%. What is volatility adjustment? 3.81% into the yield change into the base price. Into the yield change into the base price. What is convexity adjustment? Convexity into the base price into the yield change square. Into the yield change square. Any doubts till this? Any doubts till this? V plus plus V minus minus 2V0. Basically, we are trying out to find out how much is the wrong impact of duration. How much is the, divide that by 2, you have got the final convexity adjustment. When you use this formula, whether you do it for 1%, 2%, 3%, you'll almost get the same number. The convexity adjustment is going to be different at 1%, 2%, because when I asked you, sometimes you told me 0.10, then you told me 0.40, sorry, 0.10, 0.39 and 0.87 when you were doing the calculation. You gave me these percentages. You gave me these percentages. Any doubts till this? Any doubts on this? I'll wait for a minute or two. Let me know in case any doubt on the concept of convexity before then we take a break and then we start solving question. But if there's any doubt on the concept of convexity, let me know. Why we do delta change square? Why we do only positive? Why we do V plus V minus? Anywhere there is a confusion, let me know. This is the formula which is there in your material. This formula only we'll use. V plus plus V minus minus 2V0 divided by 2 into V0 into delta square. There's going to be some variant to this. I'll explain when I do the question. There is going to be some variant to this. I'll not be doing 2V0. I'll be doing something different, but I'll explain that when I do the problem. But if a problem is not asking you to calculate convexity and just the adjustment, you don't need any of this. Just do divide by 2 and we are done. Just do divide by 2 and we are done with it. But practically, all this Excel will do. In class, it's going to take us a lot of time because you'll have to first calculate the price at a lower yield, price at a higher yield, and then do the calculation, which we can't help it. We'll have to do it from an exam scenario. Any doubts on this? Clear? Okay, we'll take a 10 minutes break and then resume. Okay, I had explained you the formula of convexity where we said V plus plus V minus minus 2V0 divided by 2 into V0 into delta square. You'll multiply with, if you don't multiply with this V square, if you don't, sorry, okay, I'll explain this at the problem. Let me get it in the problem mode. There I explain it is better for me to do. Let's get into a problem on convexity. (109). Come to question 109. Question 109. The following data are available for a bond. Face value 10,000 to be redeemed at par on maturity. Coupon rate 8.5%. Years to maturity 5 years. Yield to maturity 10%. Current market price. Macauley's duration. Some question will ask modified duration. Volatility of the bond. Convexity of the bond. Expected market price if there is a decrease and increase. Add both the scenario. And increase in the YTM by 200 basis point using duration based estimate using intrinsic value method. Go through the question. Okay, let's go through this. They've given face value, they have given coupon rate, years to maturity, yield to maturity. This bond will quote at par or discount. Think. Par or discount. This is going to quote at discount. The reason is the coupon rate is 8.5%, yield to maturity is 10%. Yield to maturity is 10%. The company is not able to meet the expectation. Requirement is current market price, which is year cash flow, PVF, DCF. Macaulay's duration, which is the normal duration. Modified duration means volatility. Modified duration. So duration you will add weight and product. Volatility is going to be duration divided by 1 plus YTM. Convexity means I need the price with some yield change going up, yield going down, yield going up and yield going down, which will do a separate calculation. So year cash flow, PVF, DCF you will do at originally 10%. Question is talking about 200 basis point change here. So I'll repeat the calculation at 12 and 8. I'll repeat the calculation at 12% and 8%, which will give me the answer to this. Price of the bond when there is an increase or decrease in yield by 200 basis point, intrinsic value method, real price. The intrinsic value will give the real price. Duration based estimate is base price plus or minus volatility adjustment. Along with that you can also do convexity. Why along with you can, I'll explain. Sometimes we do, sometimes we don't do. I'll explain. Let's just proceed with the solution. Let's get first 1 2 3 and part 5b scenario. Part 5b scenario. One is current market price, second is duration, third is volatility, and the last one is intrinsic value at 8% and 12%. 200 basis point increase, 200 basis point decrease. Let's start. Any doubts in the question? For convexity, I'm going to take 200 basis point change. If problem is silent, for convexity, we'll take 1% change. For convexity, we will work with 1% change because smaller change is always better. The smaller change is always better. Let's do working note 1. Computation of current market price, duration, volatility. Current market price, duration, volatility. Year cash flow, PVF at year cash flow, PVF at how much? PVF at 10%, DCF, weight, product. I'm not going to do weight and product. I'll directly give you the answer only. Weight, product we're not going to do because I don't want to spend time on duration. Duration, time spending we don't want to do because it's a problem with convexity. I'm showing you the calculation, but we'll focus on the first 4 columns alone. How many years is the life? So 1 2 3 4 and 5. Cash flow for first year, second year, third year 850, fourth year 850, fifth year 10,850. PVF at 10%, 1 divided by 1.1. 0.909, 0.826, 0.751, 0.683, 0.621. DCF, you should do only till this. I don't want you to do beyond this part. I'll just give you the number. Else you'll end up spending time on this. I don't want to spend time on this. You can just write the final duration answer. Just the final answer. Don't even spend time on copying this, please. Because then you'll focus on the copying part rather than on the concept part. You can write it as 4.2522 years. Duration is 4.2522. 4.2522. Let's not spend on time on duration calculation because something which is not going to add value, I'll skip those steps. So below the table, current market price 9431.5. My focus would be more on convexity. This part, I don't know, I have to do it because question would want us to do and to proceed ahead, but my focus will be more on the convexity part. Macauley's duration 4.2522 years. Duration, don't worry about that 4.2522 calculation. Well, you have done so many problems, so don't try copying that also. You'll end up wasting time now because I'll be explaining something, you'll be spending time on writing things. And anyway, for every question, the printed solutions are available. So in case you want to refer later on, you have not copied it, don't worry about it. Copying is not very critical. Point number C, volatility 4.2522 divided by 1.10. Give me a 4 decimal answer. 1 plus YTM. 3.8650. Okay, 8656. 3.8656%. Now, what this means is if yield changes by 1%, price will change by 3.8656%. If this problem had not asked for convexity, then I wouldn't get into convexity calculation. I would have calculated new prices, old price plus or minus the change as per volatility. Change as per the volatility. Now, part 4 is asking for convexity. In order to do convexity, I need one price with higher yield, one price with lower yield, which anyway I'll have to do for part 5. That's why I changed the problem as increase and decrease. Only thing you will be doing is decrease, but I'll do both increase and decrease. 200 basis point is what we will take. So now we are going to calculate what is the price of the bond if you work with 8% yield and 12% yield. If you work with 8% yield and 12% yield, what is going to be the price of the bond? Then you will calculate the price using only volatility, which will have a gap. That gap can be bridged through convexity. That gap can be bridged through the concept of convexity. We are trying to reduce that gap. You cannot eliminate it fully. You want to eliminate it fully? Third derivative, fourth derivative, fifth derivative, sixth derivative, seventh derivative. You can keep going on like that. Now, next, working note 2, computation of price with increase slash decrease in YTM by 2%. Increase slash decrease in YTM by 2%. Increase or decrease in YTM by 2%. Year cash flow PVF DCF. We'll use annuity factor. Year cash flow PVF at 12%, PVF at 8%. Increase and decrease. 1 to 5 years, year 5. This is answer to part 5B of the question. You can say computation of intrinsic value. This is nothing but intrinsic value. Price is the intrinsic value. Intrinsic is present value of future cash flow. 1 to 5 and year 5. Cash flow is, I think, how much the cash flow? 850 and 10,000. Give me the 12% annuity factor and 8% annuity factor. 993. Any doubts on this? Is there a confusion? Sorry? 10 plus, okay, how I got 12 and 8? I told you, no, yeah, 10 plus 2 and 10 minus 2. 200 basis point is the change I'm going to take. 2% extra and 2% lesser. No, I'm not calculating NPV and all here. Here we are not doing any IRR calculation or NPV calculation. We are basically calculating what is the price if there is an increase in yield by 2% and decrease in yield by 2%. Basically in the market, yield has gone up. Today the price is 9431. This price will go down to 8734 if investor expectation increases to 12. And this price will increase to 10,204 if investor expectation reduced to 8%. No IRR computation is being done because IRR is given in the question. YTM is some 10%. YTM is some, this is not one positive, one negative NPV and all. There I'll have to start with year 0. I'm not getting into that. I'm basically calculating what is the likely price. What is this basically? I had showed you here, no, this way. I was calculating price for different YTMs. So if you look at the formula, I have tried doing this discounting only. Technically, it is the discounting which is being done there. Year cash flow PVF DCF was not written, and I've done the discounting for the bond for 5 years. So we are basically calculating price at two different yield. The base yield is, you can maybe write base yield is, base YTM is 10%, higher YTM 10 plus 2, 200 basis point change, 200 basis point, lower YTM 10 minus 2, 8%, higher is 12 and lower is 8. Any doubts on this? This answers part, I think 5B. 5B is done. I'll do 5A first and then I'll do convexity and we will rework on 5A. I'm going to do 5A now. Convexity would be calculated and a rework answer would be there. So next, working note 3, computation of price based on duration estimate. Computation of price based on duration estimate. Volatility of 3.8656%. Why this is called based on duration estimate? Because question said based on duration, because based on duration only we are calculating volatility. Based on duration only we are calculating volatility. Volatility of 3.8656% would mean that if yield change by 1%, price will change by 3.8656%. Price will change by 3.8656%. Price will change by 3.8656%. Any doubts on this line? This is what meaning of volatility is. If volatility is 3 point, if you have higher volatility, you have high risk. In this question, yield is changing by 2%. Yield is changing by 2%. So what will be the change in price? Double of this. Price will change by 7.731%. Price will change by 7.731% due to yield changing by 2%, 200 basis point. Yield is changing by 2%, which is 200 basis points. They can give you for increase 200, for decrease something else. For convexity calculation, I need the same percentage. Okay, when you do convexity calculation, up also same percentage, low also same percentage. I need that same number. I cannot take some other number and then try doing it. So price will change by 7.731% if yield is changing by 2%. Price when yield increase to 12%. Price when yield increase to 12% is equal to, what is the original price at 10% calculation? Now, should I reduce the 7.7312 or increase 7.7312 here? Opposite relationship, yield goes up, price will fall. Minus 7.7312%. Give me the answer, 2 decimal. $8702.33. 8702.33. I'll be able to explain the concept of convexity again with this now. 8702.33. Same thing. Price when yield decrease to 10%, sorry, 8%. 7.7312%. $10,160.67. Now, what we are trying to do is reduce the gap which you see in the two answer. 8734 vis-a-vis 8702. Right answer is 8734. Approximate answer is 8702. Practical world, I can calculate the exact answer, but whenever, see, what is the use of approximate numbers is it helps me knowing what is likely to happen. Exact answer will not be there. When I'm discussing with you, I ask you the yield has changed to 12%. Can you tell me what will be the new price? If you have to do intrinsic value, you cannot do in your mind. But you can tell me the answer using the volatility concept, saying that price will change by this much. Because whenever you are in the practical world, you want to take a quick decision. Your mind has to think, okay, yield is going to go up by 10% or 2%. Our volatility is so much. So we're having a potential loss of so much. Approximate number. Approximate number is what you will be able to give at that stage. Exact valuation, well, you can do it later. That's not the point. So here I did the calculation, but I have a gap. I have a gap. This gap, I want to bridge it through the concept of convexity. I want to bridge this. 8734, you got 8702. Will I get 8734 exactly? No. You will reduce the gap to a great extent, but you cannot get exact number and all. 10204, 10162, you will try to reduce this gap also. You will try to reduce this gap. Now, right, convexity is equal to V plus V minus 2V0 Why we are subtracting 2V0 is one higher price, one lower price divided by the average of, divided by 2 times of the base price. Divide by 2 because you are taking two numbers. V0 to express this in percentage. Whenever you divide something by price, you express it in percentage. And delta y square. Why delta y square is because yield change is the convexity is the second derivative. Convexity is the second derivative. Can I eliminate this and do the calculation? You get the final answer. If you eliminate this and do the answer, you get the final answer. Final answer is convexity adjustment. ICI may sometimes ask you to calculate convexity and convexity adjustment. This question has asked convexity. You'll have to do both. If they directly ask convexity adjustment, directly do divide by 2 and end it. What was the price you calculated when yield went up to 12%? Actual price, okay? That intrinsic value, 87. No. 8734.3. This is the intrinsic value. Intrinsic value is the real value. Intrinsic value is the real value. 8734.3. The price when yield went up. The price when yield went up. What is the price when yield came down? 10,204. Minus 2 times of base price. 2 times of Base price. What is the base price? If you divide this number by 2 and end it, that is convexity adjustment. If you divide by 2 and end it, that is the convexity adjustment. Like you have volatility and you have volatility adjustment. What is volatility? Is that percentage. What is volatility adjustment? Is you multiply that with the yield change. You multiply that with the yield change and then give the answer. So similarly, if you divide by 2 and end it, we have got the final answer, which is the convexity adjustment. But I will have to divide by the base price to express in percentage and yield change square, because we are going to multiply this with the yield change square. What is the base price? 94. Now listen, yield change is 0.02 into 0.02. 2% is 0.02. 2% is 0.02, square is into 0.02. Give me this answer. This is convexity. I have done with 200 basis point change. You can even do with 100 basis point change also. You will get approximately the same answer. This is called convexity of the bond. This is called convexity of the bond. This is expressing it in percentage. Like volatility is in percentage, convexity will also be in percentage. 9.99. I'll need a 4 decimal answer. Okay, let me just check. You guys complete it. I get it as 9.9799. This is the number I am getting. 9 point. The calculation is 8734 plus 10,204.05 is 18,938.35. Just give me a minute. Yeah. Just a minute. Yeah, 35. The gap is 75.35. The gap is 75. The numerator is 75.35. The numerator is 75.35. Denominator is, once you divide, the denominator number is 7.5452 and the answer is 9.9865. This is called convexity. This is the convexity. If you had not done those two divisions, that is that value and yield change square, you would have directly got the convexity adjustment. You would have directly got the convexity adjustment. 9.9865 is the convexity of the bond. Is the convexity of the bond. In my printed solution, I have done this in a different formula. That is also right formula only, but it is going to take a longer derivation. I thought this is better. 9.9865. Ignore that 9431.5 and 0.02, you'll get convexity adjustment. Ignore that 9431.5. This is like volatility percentage. This is convexity. Like you have volatility percentage, you have convexity. Volatility percentage into change in yield into the base price is the adjustment you make into the change, because like it was 3.86, we did into 2 and into the base price, Here you do into base price, but you do into yield square, because it is the second derivative. When I divided also, I did yield change square. Next, convexity adjustment is equal to convexity into yield change square into the base price. Convexity into the yield change square into the base price, because we divided by base price here, no? 9431.5. See, here you have divided by the base price. What is convexity adjustment is this part of the formula. Ignore the later part. Please ignore the later part. What is convexity adjustment is ignoring all that extra part. You can remove that extra part which is there. If you remove that extra part, what is there is convexity adjustment. Final answer. That is the final answer. No, you don't do into change in yield. What did you do is, see here, 9431 was the base price. Then I told you to subtract 7.7312%. What your calculator has done is this into 7.7312%, the calculator calculated. The calculator has done it as 7.7312% into the base price, and then subtracted it, which is 8702.33. So in volatility also you multiply with base price. That 7.7312% is multiplied with what? It's multiplied with the price. Volatility adjustment, how we find out is volatility change in E. Okay, after that, what you do? That is what I'm doing here. That is what I'm technically doing here. See that volatility adjustment, you can say 7.7312%. Somebody will say it is 729.16 rupees. What I'm calculating is 729.16 rupees now. What I'm calculating is 729.16 rupees. You may say it is 7.7312 percentage. I'll give you the percentage answer also. So this is convexity adjustment. Maybe to make it clear, it is in rupees. It is in rupees. How to get it in percentage? Give me a minute. You'll have to be louder. Not. Convexity is basically not in percentage, nothing. You just leave it convexity as it is. There is no unit which is given for a convexity. Convexity adjustment which you calculate can be in rupees. If it's in rupees, directly add or subtract. If it's in percentage, multiply the percentage on the base price and then to add a subtraction. Like that volatility, I said 7.7312%. What your calculator has ended up doing is, when you added 7.7312%, it added that number to the base price. It added the number to the base price or subtracted the number from the base price. Any doubts? Let's just complete this. Let's complete the convexity fully, then I come back to your doubt, because you're not able to visualize it. So let me just complete this for the time being. Just give me 2-3 minutes. Convexity is 9.9865 into 0.02 into 0.02 into 9431.5. How much? 13? 7. 37 point? Okay, 37.67. Okay, 37.67 is your convexity adjustment. You can call it as this. You can call this answer as 37.67, which my answer would have come earlier itself. I would have got this number earlier itself, or divide this by the original price. Divide this by the original price into 100 to express in percentage. 399. Okay, whatever number. The base price 37.67 divided by 9431.50, 0.399 percentage. See, the convexity adjustment finally is, like you had a volatility adjustment of 7.7312%. The convexity adjustment is 0.399 percentage of the base price, or rupees 37.67, or rupees 37.67. You can call it as 0.399 percentage, or you can call it as 37.67. Any doubts on this? I'll repeat. Just give me. You've written this first. Write it, and then let me repeat the convexity part, and then I take your doubts. You first complete the calculation. I will not take doubt. Just wait for 2 minutes and then take your doubt if you have. Okay, what we ended up doing is, first thing I told is, the price is not moving the way duration is saying? Duration is basically saying add 7%, deduct 7%. If you use 8702.33 plus 10160.67 and do double of 9431.5, you will get convexity as 0, because duration is basically thinking that it will happen this way, linear relationship. It will go up and go down at the same rate. If that happens, no convexity, because this is 0. This is 0. The numerator would have turned out to be 0. Then I got a shock. The shock is reality, it is different. Reality, it is different, because when it is going up 9431.5, the change is 697 and 772. One time it is 697, one time it is 772. Duration basically says, I don't believe in all this. Duration just said every time you take it as, just give me a minute. Duration basically said upward 729, downward 729. It just said same number. 4% upward another 729, downward another 729. 6% upward another 729, downward another 729, because duration just gives the same number, whether it is upward deviation or a downward deviation. Reality, when yield is going up, the change is 697 rupees. When yield is going down, the change is 772 rupees. So there is some problem here. There is some problem which has happened here. Now this problem I am going to sort it through the concept of convexity. What I am going to do is, what is the convexity answer you got? 37 point. This 37.67 you give an effect. How will you give an effect? Is plus another 37.67 plus another 37.67. This is the price if you give effect to convexity. If you give effect to convexity, tell me the price. You can write in sometime. Tell me the price. 10,000. Okay, the other one 8,000. 7. Okay, 8740. Convexity adjustment will always be added. No subtraction concept in convexity adjustment. Now my estimate is 8740 and 10198, which is very close to 8734 and 10204. The price which I am calculating, bringing in the convexity is very close to the price which I would have calculated using the approximate method. So the real answer is what you do through intrinsic value. Approximate answer is duration using volatility and adding convexity also. Because if you add convexity, you will get answer which is more closer to the final answer. Now why does this gap happens? Just give me a minute. This is the real situation. This is what I had showed in that graph. This is how actually price will change. It will change something like this. The actual price changes something like this. When you change or increase, price is not like it will always move up or go down at the same rate. Your convexity is saying this. This is the prediction as per the convexity. The shaded portion is the prediction as per the convexity, as per the volatility or modified duration, and the real price is this. The gap you see. This gap is the convexity adjustment. This gap is the convexity, not exactly, closer. So that when you get this, when you fill this gap, your answer will be very close to the final answer. Your answer is going to be very close to the final answer. That is what you are doing in convexity. You are trying to bridge that gap. Now tell me if there are doubts. If there are any doubts, please tell me. I can take it up. I'll give you time to write. You are yet to write something. If there are doubts, please tell me. Clear? Because this is approximate method. You see the gap, no? The gap is very less at the shorter change. Here you don't see a gap. The gap is magnifying as you do a higher increase. Duration will work only for a smaller change. Do a small change, duration will give you almost the final answer. When you do a bigger change, duration is going to fail. Like when you do IRR, the gap between two rates, if you increase, accuracy is going to go down. The accuracy is going to go down when you increase. And that's what I was saying, first derivative, second derivative, third derivative. When the change is very high, the first derivative impact is very high. Second derivative will also have an impact. Third derivative will also have an impact. Fourth also will have an impact. When the change is very small, The first derivative impact is also small. Second, nothing is there. Third, nothing is there. Because mathematically, as you have the first, second, third, fourth derivative, you'll keep seeing the impact going down. You'll keep seeing the impact going down. When you have a small change, 2% is also not a very big change. And if you see, the answer is not deviating much here. The deviation is very less. When I say very less, the 8,734 and 8,702, the gap, if you calculate it, is less than 0.1%. It is less than some point, or it's some 0.23% or 0.3%. That is okay. That is an acceptable gap because we are doing approximate method. Why approximate method is needed? Why can't I do real method? You can do real method not in your mind. You can do that in only Excel. In your mind, you can do approximate method. So when I'm doing any risk evaluation strategy, approximate method is what is going to help me in arriving at a conclusion. Because I need to quickly arrive at a conclusion. Somebody from the other side will be asking me, saying that interest rates are likely to go down. What is the likely impact? I'm doing a conference call and somebody asks this. I'll have to give a quick answer. I cannot say, okay, I'll do math working and then come back to you. So that is what the use of duration. Duration will give you an approximate impact. I want to fine tune that approximate impact. That I can do it through convexity. No, it's not due to the time. It is only because of, as time increases, the impact magnifies because the impact is for so many years. When I did a 5-year bond vis-a-vis 10-year bond vis-a-vis a perpetual bond, the impact will keep magnifying. But it's not because of time. It is because the rate of change. I did 10 becoming 12. Practical world, 10 will become 10.25. Change happens as 0.25%. Do 10.25, both will give almost the same answer. You may not see even a small deviation. You may not even see a small deviation. 10 becoming 10.25, try at home. Intrinsic value method and volatility method, you will get the same answer. Also, we have done rounding off at multiple places. If you don't do rounding off, you will not see deviation for 10 and 10.25. Any doubts on this? Yeah. You have written this convexity adjustment 37.67 rupees or 0.399 percentage. Written till 0.39. Can we proceed? Next, right? New price if convexity adjustment is also applied. New price if convexity adjustment is also applied. New price if convexity adjustment is also applied. Price when yield increased to 12%. Price when yield increased to 12%. Your base price. Start with the base price. Do the volatility adjustment and plus 37.67. You want to write it as percentage, you can also percentage. You can write as percentage also. You will end up getting the same answer. Only important thing is convexity adjustment is always to be added because yield change, minus into minus becomes plus. Minus into minus becomes plus. $8,740, which is very close to the answer you got through your intrinsic value method. What is new prices? Let me summarize again. Old price, give volatility adjustment, give convexity adjustment. Now question has asked, what is the new price based on something, some wording was there. What is the word? By duration based estimate. If it's only duration, you may or may not add convexity to it. You may or may not add convexity. I see I gave both the answer. They said, if you ignore convexity, what is the price? If you consider convexity also, which is more accurate, See, first step is giving effect of volatility, which gives your answer very close to the final answer, but you can improve the accuracy by adding convexity, which makes it almost perfect, you want to make it exact perfect, then after convexity, third derivative, where there is no name, but you calculate the third derivative, you calculate the fourth derivative, you calculate the fifth derivative, you calculate the sixth derivative, you will get to the exact answer. So we are leaving at 2 derivatives only, because beyond that, in practical world also, people don't go beyond convexity. They don't go beyond convexity. Price when yield decreased to 8%, plus 37.67. 3, 4. You'll get the same number. You'll apply that on because you got the percentage by dividing by 9431. That is a calculation error. You'll have to apply the percentage on 9431.50. Yeah. That is wrong, no? Okay, now listen, just to summarize and then I'll give you 2 minutes time to go through. This was the answer under intrinsic value. Duration based answer 8702.33, 10160.67, which indirectly has a accuracy of 99.63% and 99.57. This is accurate to that extent. It is accurate to 99.63% accuracy is there because you got answers 99.63% of the original number and the other one is 99.57% accurate. I want to improve the accuracy. I want to improve the accuracy. Add convexity also. Add convexity also, which is 8740, 10198.34. Accuracy improves to 99.93%. 100 points, there is no concept of more than 100% accurate, which means again we are becoming into inaccurate stage. More than 100 indirectly means you are getting into the inaccuracy stage. So I got accuracy technically of 99.93 and here the accuracy is 100.06. The gap is I want accuracy of 100%. I want accuracy of 100%. When can I attain accuracy of 100%? Add the third derivative, add the fourth derivative, add the fifth derivative, add the sixth derivative. What mathematically you have done here in the calculation in convexity is you are basically saying the original price was 9431. The original price was 9431. Intrinsic value set the change is 697 and 772. The intrinsic value told the change is this much. Your duration is saying change is not that much. Duration is saying change is 729 on both the sides. Duration is 729 on both the sides. Now convexity is saying 729 is wrong. So how can I improve this? On the 729. On the 729. Let me give an effect of how much was the convexity? 37.67. If I give an effect of 37.67, why it is added is why it is subtracted is a different reason. The point is this calculation is different. 9431. Ideally I should have done calculation like this. So don't worry about minus plus here. Don't get into that minus plus. That explanation will run for 5 minutes. So don't worry about that. Basic thing what you have done is 691 is the application based on convexity. 697 is the real change. 691 is the application based on convexity and 697 is the real change. 772 is the real change. 766 is the application based on convexity. 766 is the application based on convexity. The just final conclusion is I need not do all this also. The gap, sorry, the gap here is 75.3. Convexity is half of this, 37.65. The gap is 75.3. That is the two prices change. I am not talking about the change. Okay, the real change is 697 and 772. Your duration is saying apply common change. So the gap between these two 75.3. Convexity is half of this. Convexity adjustment. Okay, adjustment is half of this. That is what would have happened as convexity adjustment 37.65 or 67, whatever number you got. Whatever number you got, that is the final convexity adjustment. What we are trying to do mathematically is in one place there is a gap. You're trying to bridge that gap. You're trying to bridge that gap using this convexity adjustment. I'll wait for 2 minutes. You can go through entire solution. I've explained the logic of convexity also. Calculation is also explained. If you have a doubt on anything, please let me know. Anywhere there is a doubt, objective is to improve the accuracy of estimation. If there are doubts, please let me know. You can go to this was the answer under printed solution where a different approach was used, same answer. This is, I feel, little more extra time will be spent, so I felt the other approach is better. This could be there in the printed solution. You can follow the approach which I've done in the class. That is easier to grasp and close it. Any doubts on the convexity, let me know. Convexity exists because of this. This graph you'll have to imagine, visualize. This is what is in reality happening. If the change is common for 1% fall and 1% increase, which is not happening, 697, 772, you saw a difference. If it was common change, then the line will be a straight line. Then the line is going to be a straight line. The line is not a straight line because the change is disproportionate. The change is disproportionate. And when I started convexity, I told you, if this happens, what is the change? If this happens, what is the change? You gave me the numbers. You gave me the numbers. It was disproportionate. It was disproportionate. When you have disproportionate numbers, you are going to lead to an area called as convexity challenge. This is the second derivative. I can bring in third, fourth, fifth, sixth. You can get any number of derivatives. Not going to add much value because the accuracy from 99 point whatever 99.25 are we were there. We have reached 99.95. That accuracy is okay. Let me live with it. That's all. This accuracy also will go down if this 2% was some 10% change. If you suddenly change the yield by some 5%, 6%, please ignore duration, convexity. Don't do any of them. In a practical world, suddenly RBI increases interest rate by 4%. Don't do duration, don't do volatility, nothing you need to do. Do the real intrinsic value and complete the valuation. Because that is what is going to give you the final answer. Some small change I can absorb here, which is what is going to happen in the practical world. Any doubts? Same percentage. You can do one. No, you cannot do. For calculating volatility, you'll have to take the same percentage. Question can ask increase by 100 basis point, decrease by 200 basis point. One, sorry, convexity. So you'll calculate the convexity. Why convexity is needed is this number. Why I need this is if the yield change was 1% up and 2% down, then the convexity adjustment is this number into 0.02 into 0.02 into the price for 2% change, into 0.01 into 0.01 for 1% change, into 0.03 into 0.03 into the base price for 3% change. But when you have to calculate this, you will have to take same change, plus and minus same change. For calculating convexity, I need the same change. For calculating convexity adjustment, because finally what you are going to write is convexity adjustment, you can take your wish. If the question gives you 10%, 2% up, 1% down, I'm okay with it. I don't have a problem of 2% up and 1% down. I can use it in the formula. Like volatility, when you calculate, if you give 3% change, you do into 3. If you do 2% change, you do into 2. You do 1% change, you do into 1. Similarly, here you do into 0.01 into 0.01 into the base price, into 0.02 into 0.02 into the base price, 0.03, that is okay. The question could have asked, what is the convexity adjustment if yield changes by 100 basis point and 200 basis point and 300 basis point? Let me calculate convexity using the formula first, and then I'll apply into 0.01 into 0.01 into this price, into 0.02 into 0.02 into the price, into 0.03 into 0.03 into the price. The reason for this convexity, why I added this, is only because of this scenario which you talked about, where the problem gives you different changes, But for calculating convexity, I have to apply same yield change, because the formula also has a yield change square. There you cannot, if I ask you what is the yield change, you'll say 1%, 2%. I cannot absorb that in the calculation. I can absorb only a same change. in the calculation. Any doubts on this? So we have three numbers. One is convexity, which is this formula. Second is convexity adjustment, which is you multiply with what you added in the denominator. And third is convexity percentage, adjustment percentage. Adjustment percentage is whatever you got in rupees, divide by the price. Whatever you have got in rupees, divide that by the price. That will give you the convexity percentage. Any doubts on this? Can we proceed? Any doubts? No, convexity is one-time calculation. What I told for convexity is take 1% up, 1% down. 2% up, 2% down, 3% up, one of them. I don't want you to repeat that calculation multiple times. Like volatility is calculated once, convexity is calculated once only. After that, convexity adjustment will be different. What is convexity adjustment? Is convexity into the yield change square into the base price. So that will be different for different scenario. You okay? He's asking, can I do this by doing 1% change? Yes, you can do it, but it doesn't serve any purpose because question is asking for 200 basis point change. So I'll let me do 200 basis point. Will there be any deviation if you do 1% and do very small deviation, extremely small deviation? But you can do 1%, you can do 2%, not beyond 5% and all. 2-3% is fine. 1, 2, 3, anything is fine. Convexity is applied on that yield change square into the base price to get convexity adjustment. That convexity adjustment can be in rupees, can be in percentage. So moment you calculate convexity, which is assuming one change, then you apply it on any number. Any doubts on this? Let's come to the earlier question. We'll be in a position to do one more question on convexity. I in fact wanted to do both refunding, but refunding it's not starting. Let's do this. Go through 108. Okay, I don't have much to add in the question. Compute convexity, convexity adjustment, new price if the yield is increased by 1%. Let's visualize what is needed. For convexity calculation, I need the price at 10%. I need the price at 11%. I need the price at 9% for calculating convexity. For convexity adjustment, I'm going to whatever convexity you calculated, multiply with the yield change square, multiply with the base price. So convexity adjustment can happen with 10, 11 and 9. They've also asked for new price is equal to old price plus volatility adjustment, plus or minus volatility adjustment plus convexity adjustment. For volatility I need duration. So duration, I'm going to give you the answer. You're not going to do the calculation, but you need duration as well. As of now, I want you to do three calculation: year cash flow, PVF at 10, PVF at 11. So year cash flow, PVF at 10% DCF, PVF at 11% DCF, PVF at 9% and DCF. Get me these three prices. Duration, I'll tell you, you note it. Duration is also needed. For duration, you have to write 1, 2, 3, 4, 5. I'll write it as annuity and close now. I don't want to do separate calculation. Duration, no time spending. Is the duration needed in the question? It's not needed if this last part is not asked. If the last part is not asked, I don't need duration, because new price is old price. First give volatility adjustment, then only duration adjustment. Without giving volatility, sorry, then only convexity adjustment. Without giving volatility adjustment, you cannot directly give convexity adjustment and give the price. That is not going to work, because first derivative is volatility, second derivative only is convexity. Working note 1. Base price is going to be 100. Base price will turn out to be 100. Whether you do calculation, you don't do calculation, it's going to be 100 only. Working note 1. Computation of market price at 10%, 11% and 9%. Computation of fair price, you can call it as fair price, at 10, 11 and 9. Year cash flow, PVF at 10%, DCF, PVF at 11%, DCF, PVF at 9%, DCF. Here you will see a lot of accuracy in the answer because the yield change is small, 1% only. Base price is also only 100 rupees. So our answer would be more accurate. 1 to 5 and year 5. You complete this, I'll tell you the duration answer which I need. Once you do the table, you can just write these two numbers. Duration and volatility, you can write these two numbers. The question has just asked for increase in price. We are doing increase as well as decrease because I need two numbers. I need the increase as well as the decrease number for me to do the convexity calculation. I'll call the base price as 100. It's 100.01 because of rounding off. Let's keep it as 100. So the base price is 100. The base price is 100. Either it can increase to 103.9 or decrease to 96.26. Increase or decrease. Can we proceed? If convexity adjustment alone is asked in the question, then I need not do that in the denominator, yield change, square, V, all that is not needed because you can directly get to the answer and be done with it. But if they're asking for convexity, then you will have to do that division part. So convexity is asked in the question. Convexity is equal to V plus V minus 2V0. The logic is very simple. Again, nothing to remember in the formula. Price when it goes up, price when it goes down, and the middle price. The middle price. This is the average deviation in the value. This is the overall deviation in the value. Divide by 2. Divide by 2 because you are taking two extremes. V0 delta y square. And this is going to be the multiplier in some time. 96.26, 103.9 minus 2 into 100 divided by 2 into 100, 0.01, 0.01, exact 8. What's the number? Exactly. Okay. 8 is the convexity. The other approach gave a number as 9.6837. This the gap is rounding off. We have worked with two decimals in the calculation. We have worked with two decimals in the calculation. If I don't work with two decimals and I increase the number of decimal, the gap will go down. The other formula which we use that has given answer as 9.68 something. This gap is because of rounding off. I have done two decimals. You increase the number of decimal and do the calculation. Accuracy is going to improve. Any doubts on this? Then convexity adjustment. Convexity into yield change square into the base price. Convexity into the 8 is right. Everyone getting 8, no? Clear, no? Any doubts on this? Okay, 8 into 0.01 into 0.01 into 100. 0.8 rupees or 0.08 rupees or 0.08 percentage only. 0.08 by 100 into 100. 0.08 percentage. The convexity adjustment is 0.08 rupees or 0.08 percentage. 0.08 percentage. What is percentage? Is dividing by the base price. You divide by the base price. .08 percentage. Do I really need the earlier calculation of 8? No, I could have directly written as 0.08 and ended the question if the question had not asked for convexity. Next, new price. We have done with part 1 and part 2 of the question, which is convexity and convexity adjustment is calculated. Convexity and convexity adjustment has been calculated. Some deviation can be there in the answer. That's all rounding off. That's all rounding off. Next, new price with volatility adjustment. New price with volatility adjustment. They've asked for the new price at 11%. At 11%. New price with volatility adjustment. With volatility adjustment. 100 minus 3.7905%. 3.7905%. 100 minus 3.7905%. This is only volatility adjustment. Duration volatility I've told you to copy, okay? Duration volatility I've told you to copy the numbers. 100 minus 3.7905%. What's the price you get? 96.20. Okay, 21. 96.21. That is the price giving effect to volatility adjustment. But that is not the accurate price. That is not the accurate price. New price after convexity adjustment. After convexity adjustment, 96.21 plus 0.08. This will be more accurate to the answer you would have got in that table. More accurate. It will be more closer to that number. 96 point. Why 13? Plus no. 29 no. The table gave an answer as 96.26. The table gave an answer as 96.26. We got 96.29 now. We have got 96.29. If I had done without any rounding off, if I had done without rounding off, you would have got this numbers 9.6837 and 0.0969. Let's not worry about that. That is Perfectly fine. Our convexity adjustment in this solution is 0.0969. That is because I've not done rounding off there. I've not done rounding off. I've worked with 4 decimals. So when I do with 4 decimals, the accuracy improves. The accuracy is improving when you work with 4 decimal calculation. Let's not worry about that aspect. Convexity is very simple. V plus V minus 2V0 divided by 2, because we have to take the average, into V0 into delta y square, that is convexity, multiply with delta y square and base price, that is convexity adjustment in rupees, divide by the base price, that is convexity adjustment in percentage. Any doubts on this? With this, I'm kind of done with today's session. If there are doubts, I can take it up. I'll be starting with bond refunding in the next class. If there are doubts, let me know.